So now the relative velocity. Now when two objects A and B are moving with different velocities, then the velocity of one object A with respect to another object B is known as the relative velocity of A with respect to B. The relative velocity of one object with respect to another is the velocity with which the one object moves with respect to the other object. Hence, relative velocity is defined as the time of rate of change of relative position of one object with respect to other. Now see, if you take as VA the velocity of object A and VB the velocity of object B, then VAB is the velocity of A sorry, VAB is the velocity of A with respect to B. So hence VAB, we write VA like velocity of A minus velocity of B. Also, if suppose we have to find velocity of B with respect to A, so that will be velocity of B minus the velocity of A. Velocity of B minus the velocity of A, that is the relative velocity. Hence, we will be discussing some, now we will be discussing some examples. Okay, so now our question is, the particle moves along a circle of radius r. So you can see this is a circle, this is radius r. From this point to this point, you take this as radius r. It starts from A and moves in anti-clockwise direction. So basically its motion is like this. Okay. Anti-clockwise direction, calculate the distance travelled by the particle from A to B, from A to C, from A to D, and in one complete revolution. Also calculate the displacement in each case. So in basically in each case you have to calculate distance as well as the displacement. Okay. So first of all the A part. Now the A part is from A to B that is from here to here, means 1/4 of the rotation. Now see, distance travelled by the particle. Now the distance travelled will be see, in one complete revolution is basically 2 pi r. So this is 2, this will be 2 pi r by 4, because this is 1/4 of a circle. The distance is pi r by 2. You solve it. Now what will be the displacement? Now in case to find displacement, see, displacement will be, it is from A to B. So you have to see the initial and the final position. Now we know that this is r, this is also r. So basically this will be A modulus of AB vector, which is under root of r square plus r square, because this will be a right angle triangle in which this is r and this one is the hypotenuse, drawing a straight line, which is equals to root 2r. So this is our displacement. Now from A to C. Now from A to C, you know that is what? A to C is actually half of the revolution. So what is the distance? Distance will be 2 pi r by 2, which is pi r. So this will be the displacement, sorry, distance. Now for displacement, displacement is actually straight line joining from A to C. So which is r plus r 2r. Okay. Now we have to do the third point, which is from A to D. Now from A to D, what is A to D? A to D is actually 3/4 of the circumference. So distance is basically 2 pi r times 3 by 4. So, this goes 2 times. So, this is 3 pi r by 2 this distance. Again displacement. Now, see, displacement will be this thing from initial to final position, AD. So, this is A d vector doing the modulus, which is equals to under root of r square plus r square, which is equals to root 2 r. Okay. Now, for the complete revolution from A to again to the same point A, what will be the distance? Distance will be, now distance will be the complete circle, which is 2 pi r. Now, displacement will be, displacement is actually, it has returned to the initial position. So, which is actually 0. So, hence this case the displacement is 0. Our next example is, a car travels a distance A to B at a speed of 40 km per hour, okay, and returns to A at a speed of 30 km per hour. What is the average speed of whole journey and what is the average velocity? So, basically if you take 2 points, this is point A, this is point B, okay. So, like from A to B, it is covering at the, with a speed of 40 km per hour. When it is returning from B to A, it is moving at, it is coming at 30 km per hour. Now, what is the average speed of the whole journey? So, we know that average speed is total distance upon total time interval. So, let the distance between AB be x, okay, AB B, take it s, displacement s, and time taken to go from A to B, let it be t1 to go from here to here, and this is t2, because though the distance will be same, but the speed is different, that is why. Okay, so, we have taken let AB equals s, okay. Now, to go from A to B, now what is the time taken? T1 will be, time is distance by speed. So, distance is s we have taken. What is the speed? Speed is 40 km per hour. So, 40. This will be in hours. Now, time to move from B to A. Now, from B to A, T2 time 2 will be s by 30 hours. Distance by speed, because from B to A it is 30 km per hour. So, s by 30. Now, what is the total time taken? Total time T1 plus T2, that is s by 40 plus s by 30. So, if you solve it, this will be 7s by 120. So, this is the total time, 7s by 120. Now, what is the total distance traveled? Total distance travelled will be 2s. Total distance travelled is 2s. Now, applying sorry, the formula for average speed. Speed is what? Total distance upon total time. What is the total distance? Speed is basically total distance by total time. So, total distance is 2s upon total time, that will be 7s by 120. So, if you solve this, this will be 2s into 120 by 7s. S and S will get cancelled. This will be 34.3 kilometer per hour. So this is the average speed. I am really sorry for this. Now talking about total displacement. Now see, since the car has traveled from A to B and then B to A, means basically it is now the car has returned to its original position. So displacement is 0. So average velocity is total displacement. Now what is the total displacement? Is 0, and time to whatever be the time travel, let it be 2t, that will be 0 only. The displacement will be 0 only. Okay. Next example. Now, two trains 121 meter and 99 meter in length are running in opposite directions. Okay. The length of first train is 121 meter and the length of second train is 99 meter. They are running in opposite direction with the velocities of 40 km per hour, 40 km per hour and 32 km per hour respectively. In what time will they completely cross each other? Now see, the point is they are moving in opposite direction. Okay. So now let's consider, we have to take one as positive and other will be negative since its velocity is exactly in opposite direction to negative. So let VA equals 40 kilometer per hour and VB will automatically be minus 32 kilometer per hour. That VB will be minus 32 kilometer per hour. Now see, we have to find the relative velocities of two trains. Now, which we can find like V, suppose we are doing VAB, the velocity of A with respect to B will be VA minus VB, so which is equals to 40 minus of minus 32, that is equals to 72 kilometer per hour. So means they are moving in opposite direction, so their velocities will add up, 72 kilometer per hour. Now this is kilometer per hour and the length of the train is given in meters. So it's better to convert it to meter per second. So when you convert 72 kilometer per hour, that gives you, if you solve it, so that will give you 72 kilometer per hour will be converted to 20 meter per second. Okay. Now 20 meter per second is their relative velocity. Now what is the distance that they have to cover? They have to cover actually a distance of length of this train, length of this train. The total distance covered is 121 plus 99. So distance they will covered is 121 plus 99, which is equals to 220 meter. They have to cover a distance of 220 meter. Now time taken to cross each other. The time taken to cross will be distance is 220 and the speed is 20 meter per second, not the speed, is the relative speed. So 11 seconds. So the trains will take 11 seconds to totally cross each other. Okay. Next. Two railway tracks are parallel to west-east direction. Now see, the railway tracks are parallel, this is the direction, west-east direction. Along one track, train A moves with a speed of 30 meter per second from west to east. So see, if you see the coordinate axis, like this, I want to tell you, if you take the coordinate axis, like this is the coordinate axis, this direction is positive. So actually this is west to east, positive. This way you go, this will be east to west. Okay. So now A moves the speed of 30 meter per second from west to east, while along second track the train B moves, it's moving in opposite direction with the speed of 48 meter per second from east to west. Obvious. Calculate the relative speed of B with respect to A, that's so easy, and the relative speed of ground with respect to B. Now relative speed of ground, see the relative speed of ground with respect to B. See, as I have already told you, west to east direction we will take positive. So VA VA, which is moving in west to east direction, is 30 meter per second. West to east direction positive. And VB, I am taking from east to west, that is minus 48 meter per second. Okay. Now the first part. The first part is the calculate the relative speed of B with respect to A. So relative speed of B with respect to A is given as VBA. Simply VB minus VA, that is equals minus 48 minus 30, that is equals to minus 78 meter per second. Now, what does this minus represents? The velocity of B with respect to A. Minus 78 meter per second means from east to west. So, the velocity of B with respect to A is 78 meter per second from east to west. The minus sign gives you the direction. Now, second part. They are saying calculate the relative speed of B, the relative speed of ground with respect to B. Now, let Vg be the speed of velocity of ground. Now, velocity of ground, if we are taking Vg the velocity of ground, that is to be 0, obvious. Now, velocity of ground with respect to B, this will be Vg, applying the formula Vb, Vg is 0 minus of minus 48. So, this is actually 48 meter per second. So, this is 48 meter per second. Now, 48 meter per second is positive. So, it is from west to east, west to east. That means, the ground will appear to move from west to east with a speed of 48 meter per second with respect to B. That means, the people who are sitting in the train B will see the ground moving in opposite direction. As the train is moving from east to west, the ground, it's obvious, it is moving in opposite direction, west to east at 48 meter per second.